In the endless silent dark between the stars, a ghost is moving. For millions of years it has travelled through a coldness so profound, it makes the deepest terrestrial winter seem like a raging fire. This traveller carries no memory of warmth, no allegiance to any sun. It is an artifact of a different creation, a fragment from a stellar system that is, to us, utterly alien. We are accustomed to looking up and seeing a sky that belongs to us, a familiar celestial neighbourhood. But we're now beginning to understand that the void is not empty. It is a highway, and occasionally travellers on that highway take an exit ramp into our solar system. These are the interstellar objects, cosmic messengers from distant shores. They are time capsules, carrying within their frozen hearts the chemical secrets of the star that gave them birth. For most of human history, their existence was not even a dream. Comets were our own celestial phantoms, mysterious but familiar. They appeared in the sky as divine omens, harbingers of change, their ethereal tails painted across the constellations like a divine brushstroke. Ancient civilizations saw in them the anger of gods or the heralds of new kings. The Babylonians meticulously recorded their appearances, believing they foretold famine or flood. The Romans saw the great comet of 44 BCE as the soul of the assassinated Julius Caesar ascending to the heavens, a story that solidified the power of his heir, Augustus. For millennia, these apparitions were supernatural events, untethered from the physical world. This perception of cosmic chaos began to dissolve in the crucible of the Enlightenment. Thinkers and astronomers started to see the universe not as the whim of deities, but as a grand machine, governed by knowable mathematical laws. It was Edmund Halley, a contemporary and friend of Isaac Newton, who finally tamed these celestial beasts. Poring over historical records of cometary sightings, Halley noticed a striking similarity in the orbits of comets seen in 1531, 1607, and 1682. Using Newton's revolutionary new laws of universal gravitation, he made a prediction of breathtaking audacity. He declared that these three apparitions were, in fact, the same object, and that it would return again to our skies in the year 1758. Halley did not live to see his prophecy fulfilled, but on Christmas night of that year, the comet reappeared, precisely where his calculations said it would be. It was a profound moment for humanity. The heavens were not chaotic, they were a clockwork of sublime precision. The comet, now bearing Halley's name, proved that these wanderers were part of our solar system, bound by the same gravitational laws as the Earth, Mars, and Jupiter. They were members of our family, eccentric and distant cousins, residing in the cold, dark fringes of our solar system, in the Oort Cloud, a vast theoretical sphere of icy bodies encasing our sun. They were ours, and for more than 2 centuries that was the entire story. All the comets we had ever witnessed were domestic. The notion of a visitor from another star system remained purely in the realm of science fiction. Then, on October 19th, 2017, everything changed. A telescope in Hawaii, part of the Pan-STARRS survey, detected a faint point of light moving in a way that defied all explanation. Astronomers around the world scrambled to track it. As they plotted its trajectory, a startling, impossible truth emerged. This object was not in a closed elliptical orbit around our sun. It was on a hyperbolic path, a trajectory that was wide open. It was moving so fast that our sun's gravity could not capture it. It had come from interstellar space, and it was destined to return there. Humanity had made its first confirmed contact with a visitor from another star. They named it Oumuamua, a Hawaiian word meaning scout, or messenger from the distant past. And what a strange messenger it was. It was small, dark and reddish, but its most bewildering characteristic was its shape, inferred from the radical way its brightness fluctuated. It was likely a bizarre, elongated object, perhaps 10 times longer than it was wide, tumbling end over end through our solar system like a cosmic cigar or a shard of galactic debris. Even more mysteriously, as it sped away from the sun, it exhibited a slight, non-gravitational acceleration, a tiny push. Comets get this push from outgassing, as solar heat turns their ice into jets of vapour. But Oumuamua had no visible coma, no tail, no hint of outgassing. The mystery deepened, giving rise to tantalizing if controversial speculation. Could it be an alien artifact, a solar sail, or a defunct piece of extraterrestrial technology? We may never know. It is gone now, lost to the interstellar darkness, leaving behind a universe of unanswered questions. 2 years later, a second visitor arrived. This one, discovered by amateur astronomer Gennady Borisov, was far more familiar in its appearance. Designated 2I/Borisov, it looked and acted like a conventional comet. It sported a magnificent coma and tail as the sun's warmth vaporized its surface. It was a profound relief to scientists. It demonstrated that Oumuamua's strangeness might be the exception, not the rule. It suggested that other star systems, like our own, are populated with icy bodies that behave in predictable ways, and yet, even in its familiarity, 2I/Borisov was deeply exotic. It was a piece of another world, and we were hungry for more. The vigil continued. Day and night, automated eyes scan the heavens. One such system is ATLAS, the Asteroid Terrestrial Impact Blast Alert System. It is a robotic sentry designed to warn us of incoming asteroids. But in its tireless survey of the sky, it sometimes stumbles upon treasures, and so it was that the third confirmed traveller from the interstellar void was found. Catalogued as 3I/Atlas, this faint smudge of light began its own extraordinary journey into our awareness, into our telescopes, and into our scientific scrutiny. Like its predecessors, its orbit was a giveaway, a hyperbolic arc that was a clear signature of an origin beyond our sun's grasp. Another ghost had arrived from the interstellar ocean. For astronomers, the arrival of such an object is a call to arms. It is a fleeting opportunity, a chance to interrogate a relic from a place we can never hope to visit. We cannot send a probe to it, not on such short notice. We cannot touch it or sample its ancient ice. But we have a tool, a method of interrogation so powerful it allows us to read the chemical soul of an object from hundreds of millions of miles away. This tool is called spectroscopy, and it is one of the pillars of modern astrophysics. It is the science of decoding light. Imagine receiving a sealed, indestructible bottle that has washed ashore after crossing a vast, unknown ocean. You cannot open it, but you are desperate to know its origins. The light that reflects off this bottle, or shines through it, is your only clue. If you were to pass that light through a prism, you would see it break apart into a familiar rainbow of colours, a spectrum. But if you looked very closely, you would notice something extraordinary. Imprinted upon that smooth rainbow are tiny dark vertical lines, like a barcode on a product in a supermarket. These dark lines are absorption lines. They are the chemical fingerprints of the atoms and molecules that the light has encountered. Every element on the periodic table, every conceivable molecule, has a unique and unchangeable spectral signature. Hydrogen atoms, for example, will always absorb light at very specific wavelengths, creating a precise pattern of dark lines. Sodium atoms will absorb light at different wavelengths, creating their own distinct pattern. Water molecules, carbon monoxide molecules, complex organic compounds, each one leaves its own indelible set of lines on the spectrum of light. By capturing the light from a distant star or comet, and by carefully analysing this cosmic barcode, we can determine, with astonishing accuracy, exactly what that object is made of. We can identify the composition of its atmosphere, the minerals on its surface, the gases spewing from its core. It is a form of cosmic alchemy, turning light into knowledge. This is the tool we would turn upon 3I/Atlas. The life of an interstellar comet is one of unimaginable loneliness and cold. For eons it drifts in the near absolute zero of deep space. Its constituent parts, its water ice, its frozen carbon monoxide, its methane, its dust, are locked in a pristine primordial state. It is a perfect, unaltered sample of the protoplanetary disk from which it was born. Then, by a chance of cosmic geometry, its path intersects with our solar system. It begins the long fall inward, toward our star, and as it gets closer, the environment changes, dramatically and violently. The faint warmth of the distant sun becomes a relentless, scorching blaze. This critical moment of passage, the closest approach to the star, is called perihelion. For a comet, perihelion is a trial by fire. The solar radiation, a torrent of photons and charged particles, batters the nucleus. The ancient ices, which have been stable for millions or perhaps billions of years, begin to sublimate, turning directly from a solid into a gas. This outgassing is what creates the magnificent features of a comet. The gas and dust erupt from the surface, forming a vast glowing cloud around the nucleus called the coma, which can swell to be larger than the planet Jupiter. The solar wind then pushes this material away from the sun, sculpting it into the iconic tail that can stretch for millions of miles across space. This process is not gentle. It is a violent transformation. The comet is shedding its skin, revealing its inner layers. It is broadcasting its chemical composition into the solar system. This is the moment astronomers live for. As 3I/Atlas rounded the sun, its post-perihelion phase began. This is the period after its most intense solar encounter. It is now a changed object. The most volatile ices on its surface have been boiled away. Deeper, more primordial layers may have been exposed. The chemical soup in its coma is at its richest and most complex. This is the prime time for spectroscopic analysis. This is when the ghost truly begins to speak, and so telescopes across the world and in orbit above it turned their gaze towards this fleeting visitor. They began to gather the light, to collect the photons that held the secrets. And in a stream of data designated AT25P11, the story began to unfold. The first thing the spectrum tells us is often what is most abundant. As expected, the spectral signature of the hydroxyl radical, OH, was strong. This is a telltale sign of water. The sun's ultraviolet radiation is so intense that it breaks down the water molecules, H2O, spewing from the comet's nucleus into hydrogen, H, and hydroxyl, OH. Finding this signature confirmed that 3I/Atlas, much like the comets of our own solar system, was a repository of water ice. This is a crucial piece of the puzzle. It suggests that water, the fundamental ingredient for life as we know it, is likely a common component in the formation of planetary systems across the galaxy. The star system that birthed 3I/Atlas, wherever it may be, likely had the same raw materials for life that our own did. The universe, it seems, uses a common recipe book, but it is in the subtle details, the trace elements, the less abundant molecules, that the most compelling stories are found. Scientists began to search the spectrum for the fingerprints of other compounds. They looked for the telltale barcodes of carbon monoxide, carbon dioxide, methane, and ammonia. The relative abundances of these ices tell a detailed story about the environment in which the comet formed. A comet born in a colder region of a protoplanetary disk, far from its parent star, will have a different ratio of these volatile ices than one formed in a warmer, closer-in region. The spectrum of 3I/Atlas was a map to its birthplace. The analysis of the post-perihelion data began to paint a fascinating picture. Compared to a typical Oort Cloud comet from our own solar system, 3I/Atlas appeared to be significantly depleted in carbon monoxide. This was a tantalizing clue. In our solar system, the amount of carbon monoxide in a comet is a strong indicator of its formation temperature. The lack of this highly volatile gas might suggest that 3I/Atlas formed in a relatively warm environment, perhaps closer to its parent star than our own comets did. Imagine a solar system in the making, a swirling disk of gas and dust around a young star. The fact that this visitor may have formed in an inner, warmer region and was then ejected into interstellar space hints at a violent and dynamic past for its home system. Perhaps the gravitational influence of a giant migrating planet, a hot Jupiter, kicked this object out of its orbit, sending it on its multi-million-year journey through the void. The spectrum was not just a list of chemicals, it was a page from a planetary biography. Furthermore, scientists delved even deeper into the light, examining not just the elements, but their isotopes. Isotopes are versions of an element that have a slightly different mass. For example, most hydrogen atoms have just one proton in their nucleus, but a heavier isotope of hydrogen, called deuterium, has one proton and one neutron. The ratio of deuterium to regular hydrogen, known as the D/H ratio, is a powerful tracer of an object's history and origin. In our solar system, this ratio varies depending on where an object formed. Objects that formed farther from the Sun, in colder regions, tend to be enriched in deuterium. Measuring the D/H ratio in the water vapour of 3I/Atlas's Comet was a key objective of the Post-Perihelion observation campaign. This is painstaking work. The spectral signature of deuterated water is faint, easily lost in the noise of the data. But the results, once teased out of the terabytes of information, provide a profound connection. If the D/H ratio in 3I/Atlas was similar to that of Earth's oceans, it would bolster the theory that comets delivered a significant portion of our planet's water. If the ratio were wildly different, it would suggest that the chemistry of its home system evolved along a different path. The ongoing analysis of datasets like AT25P11 is akin to an archaeological dig. Each new spectral line identified, each isotopic ratio calculated, is another pottery shard, another fossil, helping us reconstruct a world we have never seen. It allows us to compare the genesis of our solar system with the genesis of another, anonymous star system light years away. The post-perihelion spectrum also allows us to study the dust. Comets are not pure ice. They're often described as dirty snowballs. They contain a significant fraction of silicate minerals and carbon-based compounds, the very stuff that forms rocky planets like Earth. As the ice vaporizes, it liberates this dust, which then streams away in the tail. By analysing the light reflected by these dust grains, we can determine their size, their shape, and their composition. Was the dust in 3I/Atlas similar to the dust in our comets? Did it contain olivine and pyroxene, common minerals in our solar system? Or did it hold exotic mineralogies, pointing to a different set of primordial building blocks? The answers to these questions have staggering implications. They help us understand our own uniqueness, or our own commonality. If interstellar objects consistently show chemical compositions similar to our own comets, it implies that the basic processes of planet formation are universal. It suggests that across the Milky Way, countless star systems are being built from the same standard set of ingredients. This raises the probability that other Earth-like planets, with similar compositions and water inventories, might be abundant. It would mean we live in a galaxy that is fundamentally hospitable to the kind of world we call home. But if future visitors show radically different chemistries, it might imply that our solar system is an outlier, a special case. It could mean that the specific conditions that led to Earth are far rarer than we imagine. Each interstellar object is a new data point in this grand cosmic census. The journey of 3I/Atlas through our solar system, especially its state after its fiery perihelion pass, forces us to confront an even more profound and unsettling idea. For centuries, we have viewed our solar system as a closed, isolated ecosystem. But we now have undeniable proof that this is not the case. Material is being exchanged between star systems. Our Sun and its planets are not an island, but part of a galactic archipelago, with cosmic flotsam and jetsam constantly drifting between its shores. This realization opens the door to one of the most exciting and debated concepts in science, panspermia. Panspermia is the hypothesis that life itself, or at least its essential building blocks, can be distributed throughout the galaxy. The idea is that microorganisms or complex organic molecules could be encased within an object like a comet or asteroid. If that object is then ejected from its home star system by a gravitational encounter, it becomes an interstellar traveller. Protected from the harsh radiation of deep space within the icy heart of the comet, these biological passengers could survive a journey of millions of years. If this vessel then happens to be captured by another star system and collides with a suitable planet, it could seed that world with life. It is a breathtaking concept that life on Earth may not have originated here, but arrived as a microscopic alien delivered by an interstellar comet. Before the discovery of objects like 3I/Atlas, panspermia was largely a philosophical speculation. But now we have the evidence. We know the delivery mechanism is real. Interstellar objects are not a theoretical possibility. They are a measured reality. The post-perihelion spectrum of these objects is our first, best chance to search for the chemical precursors to life. Are there complex organic molecules like amino acids present in their comas? The discovery of glycine, a simple amino acid, in the coma of the Comet 67P/Churyumov-Gerasimenko by the Rosetta mission proved that these molecules exist in our own comets. Finding them in an interstellar object would be a monumental discovery. It would demonstrate that the building blocks of life are not just present in our solar system, but are being actively transported from one star system to another. The data contained in AT25P11 is not just a chemical inventory. It is a search for our most distant relatives, for the very seeds of our own existence. The study of these interstellar nomads is still in its infancy. We are passive observers, reliant on the chance arrivals of these messengers. We catch what we can of their faint, fleeting light, and we do our best to decode the stories whispered within it. But humanity is not content to simply wait and watch. Already, space agencies are designing missions with a singular audacious goal: to intercept and study an interstellar object up close. The European Space Agency's Comet Interceptor mission, for example, is designed to be a rapid response spacecraft. It will be parked in a stable location in space, waiting. When the next suitable interstellar visitor is detected on its way into the solar system, the interceptor will be deployed on a trajectory to fly by it, perhaps even send a small probe into its coma. Imagine the data we could gather then, not just a spectrum from afar, but a direct mass spectrometry reading of the gases, high-resolution images of the nucleus, revealing its geology and structure, measurements of the dust particles, analysing their individual composition. It would be like moving from looking at the sealed bottle on the shore to having a full laboratory to analyse every drop of its contents. The legacy of objects like Oumuamua, Borisov, and 3I/ATLAS is that they have transformed our ambition. They have shown us that the galaxy is sending us messages. Now, we are building the technology to read those messages with perfect clarity. For now, we are left with the faint light captured by our telescopes, with datasets like AT25P11. Scientists will continue to mine this information for years, refining their models, debating the implications of every subtle spectral feature. The post-perihelion spectrum of 3I/ATLAS is a snapshot of a ghost in motion. It is the fading echo of a violent sun-scorched transformation. It tells a story of a different star, of a different planetary nursery, of a long cold journey, and of a brief fiery encounter in our home. This single dataset represents a monumental collaborative effort, a testament to our species' insatiable curiosity. It connects the robotic eyes of a survey telescope in Hawaii to the giant mirrors of observatories in Chile and Spain, to the supercomputers that process the data, and to the human minds that struggle to interpret it. As 3I/ATLAS speeds away from us now, its brief moment in the sun is over. It is heading back out into the unfathomable abyss from whence it came. It will not return for millions of years, if ever. It will drift once more into the silent, frozen darkness, carrying the memory of our sun's heat within its newly sculpted form. We were privileged to witness a small part of its endless journey, and in its light we saw a reflection of ourselves. We saw the water that fills our oceans, the carbon that forms our bodies, the dust that built our world. We saw evidence that the cosmos is not a collection of isolated islands, but a connected, interwoven whole. The ghost has passed, but its message remains, encoded in a stream of light, a whisper from another star reminding us that we are, all of us, made of stardust, and that the universe is far larger, stranger, and more intimately connected than we ever dared to imagine. The search for the next messenger is already underway. The darkness is full of them. We only need to keep watching. The cosmos does not breathe, nor does it feel the weight of the lives that cling to its rocky outcroppings. It is a structure of absolute, unfeeling precision, a clockwork of staggering scale where the gears are forged from the mass of worlds, and the springs are the invisible, warped curves of space-time itself, Within this grand engine there is no malice, no mercy, and no intent. There is only the relentless mathematical mandate of orbital mechanics, a silent grinding of celestial teeth that has persisted for 4.6 billion years. This is the cold machine, an assembly of matter and energy governed by laws that were written in the first white-hot moments of existence, and it operates with a terrifying indifference to the biological dust that observes its movements. Deep within the frozen periphery of this system, far beyond the reach of the sun's warmth, a jagged fragment of ice and carbon has begun a journey that was set in motion before the first human cities were raised from the Earth. This object, designated by the clinical nomenclature of C/2023I3, and known to the watchers of the sky as Tsuchinshan-ATLAS, has been dislodged from an 80,000-year slumber. It is not a guest arriving for a brief visitation, nor is it a wandering pilgrim of the void. It is a projectile. It is a mountain of frozen gas and ancient dust that has been released from the gravitational lock of the outer dark, now accelerating with increasing fury toward the inner sanctum of the solar system. The engine of the Sun, a furnace of nuclear fusion containing over 99% of the system's total mass, acts as the central pivot for this movement. It is a gravitational trebuchet of such power that it bends the path of everything that dares to approach its burning heart. As the comet falls, it is being loaded into this cosmic sling. The Sun does not welcome it. It merely catches the object in its vast invisible net and prepares to whip it across the orbital planes of the inner planets. The machine is resetting its gears, and the world of man happens to stand directly in the path of its next mechanical stroke. The silence of the void is absolute, yet the momentum of this frozen bullet carries a weight that defies the stillness. For 80 millennia, the comet remained a silent witness to the outer dark, a relic of the primordial cloud that birthed the planets themselves. Now the gravity of the central star exerts a pull that cannot be denied. Each passing second adds to its velocity, a slow-motion fall that will eventually reach speeds of dozens of kilometers per second. There is no friction to slow its descent, no atmosphere to cushion its approach. There is only the vacuum and the increasing intensity of the solar wind, a stream of charged particles that begins to lash against the comet's frozen skin. As it draws closer, the cold machine begins to exert its transformative power. The ice, which has remained solid since the dawn of human consciousness, starts to feel the first stirrings of the sun's radiation. This is not a gentle warming, but a violent awakening. The vacuum of space does not allow for liquid water. Instead, the solid core of the comet undergoes sublimation, tearing itself apart to create a glowing shroud of gas. The projectile is arming itself, trailing a banner of debris that will eventually stretch across millions of kilometers of the void. To the inhabitants of the third planet, this may appear as a wonder, a streak of light across the tapestry of the night sky. But to the machine, it is simply a byproduct of the friction between mass and energy. The trajectory is fixed. The laws of Newton and Einstein provide the blueprint for its path, a curve so precise it could be calculated to the millimeter if one had the eyes to see the underlying geometry of the universe. There is no deviation, no choice, and no escape from the physics of the encounter. The comet is a high-velocity gear moving into alignment with our own, a convergence of two separate histories meeting at a single point in the vastness of the three-dimensional grid. We are witnessing the clockwork in motion, the slow, grinding turn of a celestial wheel that takes lifetimes to complete a single revolution. In the cold light of the stars, the comet C/2023I3 represents a reminder of our own fragility. We exist within the narrow tolerances of this grand mechanism, shielded by a thin veil of atmosphere and a magnetic field that is itself a gear in the planetary engine. The comet's arrival is a test of the machine's stability, a kinetic event that highlights the scale of the forces at play. As it nears the sun, the gravitational trebuchet prepares to release its hold, flinging the mountain of ice back out into the darkness from which it came, but not before it passes through the narrow corridor of our own orbit. The stage is set, the gears are locked, and the projectile is in flight. This is the reality of the solar system, a place of terrifying beauty and absolute clockwork precision. The comet Tsuchinshan-ATLAS is merely the latest component to be processed by the engine. As it accelerates, the energy of its motion builds, a potential force that has been accumulating for 80,000 years, now ready to be unleashed in a display of light and speed. There is no stopping the machine once the gears have engaged. We can only watch as the projectile completes its arc, a frozen relic of the past screaming into the present, driven by the invisible hand of gravity toward its inevitable appointment with the Sun and the Earth. The journey began in a realm where the Sun is little more than the brightest star in a crowded firmament, a distant spark struggling to cast its influence across the staggering abyss. This is the Oort Cloud, a colossal spherical shell of frozen waste that envelops the solar system like a translucent shroud of ice and forgotten history. It lies at the absolute edge of the Sun's sovereign reach, 50,000 astronomical units away from the warmth of the inner worlds. To cross this distance at the speed of a commercial aircraft would take over 6 million years. Even light itself, the fastest messenger in the cold machine, must travel for nearly an entire year just to reach this desolate frontier. Here, the temperature hovers mere fractions of a degree above absolute zero, the point where all molecular motion ceases and the very concept of heat becomes a distant alien memory. It is a graveyard of the primordial era, containing trillions of icy fragments that failed to become part of the Great Planetary Gears 4.5 billion years ago. Among these trillions of silent sentinels lay the nucleus of the object now known as C/2023A3. For thousands of centuries it existed in a state of perfect crystalline stasis, a jagged mountain of water ice, frozen carbon dioxide and silicate dust no larger than a city. It was a component of the machine that had been set aside, a spare part floating in the dark, tethered to the distant sun by a gravitational thread so thin it was almost non-existent. In this place, there is no wind, no sound, and no change. The comet was a relic of the solar system's violent birth, a time capsule of the chemical signature that existed before the Earth had cooled or the first oceans had formed. It was a dormant entity, a ghost of the deep past waiting for a reason to move. The equilibrium of this frozen tomb was not destined to be eternal. The cold machine of our solar system is not an isolated system. It exists as a small gear within the much larger, more complex engine of the Milky Way galaxy. As our Sun orbits the galactic centre, it bobbles up and down through the crowded disk of stars, encountering different densities of matter and varying gravitational pulls. Every few million years, a neighbouring star wanders close enough to the solar periphery to disturb the delicate balance of the Oort Cloud. Or perhaps in this instance it was the subtle rhythmic tug of the galactic tide, the collective gravity of the hundreds of billions of stars in the galactic disk that finally reached into the dark to touch the comet's resting place. A nudge was applied, a force no more significant than the pressure of a human finger against a mountain, yet in the frictionless environment of the void, it was enough. The gravitational thread that held the comet in its distant circular orbit tightened and then snapped. The object's momentum was stolen, its orbital velocity reduced by a fraction of a percent. This infinitesimal shift was the catalyst for a transformation. The comet began to fall. At first, the movement was imperceptible, a slow, agonizing drift toward the distant golden dot of the sun. But in the vacuum of space, there is no resistance to arrest such a descent. The fall became a plunge, the beginning of a multi-millennial journey toward the inner sanctum. This was the moment the frozen relic became a moving threat. The potential energy that had been stored within the comet's position for 80,000 years began to convert into kinetic energy. It was a slow-motion acceleration, a descent into a gravitational well that would eventually see the object travelling at speeds that defy human comprehension. As it moved inward, it left behind the absolute stillness of the Oort Cloud and entered the vast, empty gulfs that separate the stars. It crossed the Kuiper Belt, another ring of icy debris, and began its long transit toward the orbits of the outer giants, Neptune, Uranus, Saturn, and Jupiter. These massive governors of the inner system, with their own immense gravitational fields, acted as secondary gears, their presence warping the space around the falling comet, subtly refining its path as it screamed toward the centre. The comet was now a bullet fired from the edge of the dark, aimed with the mathematical certainty of a universe that does not care for the consequences of its motions. It carried with it the chemical volatility of the early solar system, methane, ammonia, and complex organic molecules that had remained frozen since the dawn of time. As the distance to the sun decreased, the intensity of the light began to rise. The dark, soot-covered surface of the nucleus, which had not seen a significant photon in eons, began to absorb the first hints of solar energy. The transition was underway. The cold machine was drawing the projectile in, preparing to use the sun as a pivot for a high-speed maneuver that would bring this ancient wanderer into a direct encounter with the world of the living. The silence of the Oort Cloud was gone, replaced by the accelerating whistle of a mountain falling through the vacuum, driven by the relentless invisible hand of gravity. On the night of January 9th, 2023, the glass eyes of the Purple Mountain Observatory in China were turned toward the constellation of Serpens, scanning the deep fields of the sky for anything that defied the static arrangement of the stars. In the silence of the high-altitude air, the electronic sensors of the telescope, chilled to temperatures far below freezing to minimize thermal noise, captured a stream of photons that had travelled for hours across the solar system. Among the millions of pinpricks of light, a single, infinitesimal smudge of grey appeared. It was a ghost in the machine, a tiny deviation in the expected pattern of the heavens. This data point was logged, a digital ghost recorded on a silicon chip, but for a brief window of time, the object slipped back into the anonymity of the void. The machine of human observation had caught a glimpse, but the gears of confirmation had not yet fully turned. It was not until February 22nd, 2023, that the mechanism of discovery engaged a second time. Thousands of miles away, under the dark canopies of the South African sky, the Asteroid Terrestrial Impact Last Alert System, known by its acronym ATLAS, independently flagged the same moving coordinate. The automated software designed to protect the planet from the kinetic hazards of the cosmos recognized the motion of the object against the fixed backdrop of the distant galaxies. This was no ordinary asteroid dwelling in the belt between Mars and Jupiter. The mathematical vectors did not compute for a local resident. As the data from China and South Africa were merged into the global network of the Minor Planet Center, the true nature of the intruder began to emerge from the noise. The object was assigned the clinical designation C/2023A3, a name that stripped away the mystery and replaced it with the cold logic of a filing system. To the astronomers staring at their glowing screens, the realization of what they had found was a moment of profound, quiet wait. By tracking the position of the smudge over several weeks, the orbital computers began to trace a path that reached back into the abyss of the Oort Cloud. The trajectory was a long-period ellipse, a curve so elongated that it bordered on the hyperbolic. This comet was not a frequent visitor. It was a relic that had not seen the light of the inner solar system for 80,000 years. The last time this mountain of ice had been this close to the sun, the Neanderthals were still walking the plains of Europe, and the human species was a fragile local phenomenon, unaware of the clockwork turning above their heads. The detection was a triumph of the fragile senses of a biological species attempting to map a relentless mechanism. These telescopes, constructed of polished glass and complex alloys, are essentially optical probes extended into the dark, trying to find meaning in the motion of the gears. The astronomers observed that the comet was currently located far beyond the orbit of Jupiter, yet it was already showing signs of a faint coma. This early activity suggested a nucleus of significant size and volatility. It was a new comet in the astronomical sense, one that had not been heat-treated by frequent passes near the sun, making its behaviour unpredictable and potentially spectacular. As the weeks turned into months, the data logs grew. Every major observatory on the planet began to pivot its instruments toward the incoming projectile. They measured its brightness, its velocity, and the subtle shifts in its colour. The machine of human science was attempting to predict the behaviour of the larger celestial machine. They calculated the perihelion, the point of closest approach to the Sun, and the perigee, the closest point to the Earth. The numbers were refined with every new observation. A distance of 58 million kilometres from the solar surface, a speed that would exceed 200,000 kilometres per hour. the realization settled in that this was a high-velocity kinetic event in the making. The comet was not merely passing through. It was on a collision course with the inner solar system's gravitational well. It was moving in a retrograde fashion, travelling against the flow of the major planets, which ensured that any encounter would be a high-speed affair. The telescopes recorded the comet as it crossed the invisible boundaries of the outer system, moving past the realm of the gas giants and into the territory of the rocky worlds. The tone of the scientific community was one of disciplined anticipation. There was no room for hyperbole in the data logs, only the cold reporting of magnitudes and arcseconds. Yet, beneath the technical language lay the understanding that they were watching a rare alignment of the gears. The Comet C/2023A3 was a messenger from the dawn of the system, a piece of the original construction material of the solar machine, now being drawn back into the forge. The tiny, fragile sensors of Earth had done their job. They had identified the incoming projectile and mapped its path. Now, all that remained was to watch as the laws of physics took over, driving the mountain of ice toward its inevitable, incandescent encounter with the sun. The clock was ticking, and the next movement of the cold machine was about to begin. The architecture of the solar system is defined by a disciplined prograde choreography. For billions of years, the 8 major planets, their myriad moons, and the vast majority of the debris within the asteroid belt have circled the Sun in a singular, counterclockwise direction. This uniform rotation is a lingering signature of the primordial disk from which all matter in this neighbourhood emerged. It is a harmonious movement, a synchronization of gears that ensures the relative velocities between the worlds remain manageable. However, the Comet C/2023A3 is an agent of mechanical discord. Having descended from the spherical shell of the Oort Cloud, its entry into the inner sanctum was not restricted to the flat plane of the planetary disk. It arrived at an angle that defies the established order, locked into a retrograde orbit. It is moving against the grain of the entire solar machine, a ghost traveller driving the wrong way down a high-speed celestial thoroughfare. This retrograde motion is the defining characteristic of the upcoming kinetic event. To understand the violence of this geometry, one must look at the vectors of the two bodies. The Earth travels along its orbital path at a speed of approximately 30 km per second, a velocity maintained by the delicate balance between its forward momentum and the Sun's inward pull. When a prograde object, an asteroid or a short-period comet, approaches the Earth from behind or the side, the relative speed of the encounter is the difference between their velocities. It is a gradual closing of distance, a gentle drifting together in the dark. But with Tsuchinshan-ATLAS, the geometry is flipped 180 degrees. Because the comet is moving in the opposite direction of the Earth's rotation, the two objects are not drifting. They are closing the gap with their combined speeds. The physics of this encounter are governed by the uncompromising laws of Newtonian mechanics. Momentum, the product of mass and velocity, is a conserved quantity that dictates the severity of any interaction within the vacuum. As the comet falls deeper into the Sun's gravity, its velocity increases according to the inverse square law, transforming its potential energy into a terrifying kinetic display. By the time it reaches the orbital path of the Earth, it will be screaming through the void at tens of kilometers per second. When this velocity is added to the Earth's own orbital speed, the resulting relative velocity creates a high-speed intersection that occurs at over 70 kilometers per second. This is not a mere flyby. It is a calculated, inevitable meeting of two massive parts of the machine moving at a combined speed of over 250,000 kilometers per hour. The invisible curves of space-time act as the rails for this encounter. The comet follows a geodesic, the shortest path through the warped space created by the Sun's immense mass. There is no steering, no correction, and no friction to alter its course. Every gram of the comet's icy mass is a carrier of kinetic energy, a mathematical certainty hurtling toward a specific point in the four-dimensional grid of our system. The astronomers mapping this path see not just a streak of light, but a vector, a line in the dark with a fixed direction and a growing magnitude. They calculate the intersection points with the precision of master watchmakers, knowing that the gears of the Earth and the comet will mesh at a specific coordinate on a specific day in October. The indifference of the machine is nowhere more apparent than in this geometry. The retrograde path of the comet was determined by the random orientation of its initial nudge in the Oort Cloud 80,000 years ago. A shift of a single degree in its starting position would have sent it on a completely different arc, perhaps missing the inner solar system entirely, or entering in a prograde fashion that would have made its passage a slow, lingering affair. Instead, the cold machine has dictated a head-on approach. This ensures that the comet's passage through our sky will be brief, intense, and marked by a brilliance born of its extreme speed. As the comet approaches the orbital plane, the gravitational influence of the planets begins to exert subtle tugs on its trajectory. Jupiter, the great governor, and Saturn, the ringed weight, add their own vectors to the comet's motion. These are the secondary gears of the engine, refining the projectile's aim. Yet the comet's momentum is so vast that these perturbations are minor corrections rather than course changes. It remains a bullet fired across the bow of the Earth, a reminder that the solar system is not a static map but a dynamic moving assembly. The geometry of the encounter is a testament to the scale of the forces at work, a high-velocity intersection of ice and rock, choreographed by the silent, grinding laws of a universe that moves with the precision of a clock and the heart of a stone. The vectors are locked, the momentum is absolute, and the intersection is fast approaching. As the projectile penetrates deeper into the inner sanctum, it crosses an invisible but decisive boundary known as the frost line. This is the thermal frontier of the solar machine, located approximately 5 astronomical units from the Sun, where the radiation of the central star becomes potent enough to strip away the protective shield of absolute cold. For 80,000 years, the comet C/2023A3 remained a dormant, frozen monolith, its chemical secrets locked behind a crust of dark, organic soot. But as it traverses the orbit of Jupiter, the equilibrium shatters. The Sun's light, once a distant and harmless glimmer, now hammers against the nucleus with increasing ferocity. The chemical awakening of the comet begins not with a whisper, but with a violent structural convulsion. The process of sublimation takes hold, a phase transition where matter skips the liquid state entirely, leaping from solid ice to expansive gas in the vacuum of the void. Deep within the porous interior of the nucleus, pockets of frozen carbon dioxide and carbon monoxide reach their critical temperatures first. These volatile ices, which sublime at much lower temperatures than water, begin to boil beneath the surface. Pressure builds within the dark, icy matrix until the outer crust can no longer contain the expanding gases. The surface of the comet ruptures. Geysers of vaporized gas and ancient dust scream into the vacuum, erupting in colossal jets that act like tiny erratic thrusters, causing the nucleus to tumble and wobble in its flight. This outgassing creates the coma, a temporary and ethereal atmosphere that begins to shroud the solid nucleus. Though the heart of the comet is a mountain only a few kilometers in diameter, the coma expands until it reaches staggering proportions. It swells into a glowing sphere of gas and dust that can measure hundreds of thousands or even millions of kilometers across. In this moment, the comet's influence occupies a volume of space larger than the planet Jupiter, the king of the planetary gears. Yet this atmosphere is a phantom, a tenuous cloud of molecules so thin it would be considered a high-quality vacuum in any laboratory on Earth. It is a testament to the machine's ability to transform a small, insignificant mass into a spectacle of celestial scale. As the comet draws closer to the Sun, moving through the orbits of the inner planets, the radiation pressure and the solar wind, a relentless stream of charged particles, begin to interact with the expanding coma. This interaction creates the most iconic feature of the celestial intruder, the tail. The cold machine does not allow the comet to carry its atmosphere in a symmetrical shroud. Instead, it strips the gas and dust away, blowing it back into the void. Two distinct structures emerge. The first is the ion tail, a straight, narrow ribbon of ionized gases, glowing with a ghostly blue light as the molecules are buffeted by the solar wind. This tail always points directly away from the Sun, a compass needle of glowing plasma that reveals the direction of the solar gale. The second structure is the dust tail, a broader curved banner composed of microscopic grains of silicate and carbon that were once trapped in the comet's ice. Unlike the ions, these dust particles are heavier and are influenced by the orbital momentum of the comet itself. They linger in space, tracing the path the nucleus has travelled, creating a luminous arc that can stretch for tens of millions of kilometres. This dust is the debris of the early solar system, material that has not seen the light of day since the planets were molten spheres. As the comet sheds this material, it leaves a trail of breadcrumbs across the orbital plane, a graveyard of ancient matter that will persist long after the nucleus has retreated. The energy of the sun now saturates every centimetre of the comet's surface. Water ice, the primary constituent of the nucleus, begins to sublime in massive quantities as the object passes within 2 astronomical units of the star. The rate of mass loss is staggering. The comet is shedding hundreds of tons of material every second. This is the price of admission to the inner solar system. The machine demands a sacrifice of mass for the privilege of the close encounter. The nucleus, once a solid and unchanging relic, is now a crumbling, venting wreck, losing its integrity as the solar furnace melts the glue that has held it together for billions of years. The visual transformation is complete. The faint smudge of light detected by the telescopes of Earth has become a fully realized celestial apparition. The coma glows with the reflected light of the sun, while the tails provide a sense of motion and direction, a visual representation of the high-velocity kinetic event unfolding in the dark. The comet is no longer just a rock. It is a chemical engine, powered by the radiation of the star it is falling toward. It is a banner of light and dust, a screaming projectile that announces its presence to any world that happens to be watching. The gears of the solar system continue to turn, and the comet, now a brilliant and volatile ghost, is being drawn ever faster into the sun's gravitational forge, where the ultimate test of its structural resolve awaits. The date is September 27th, 2024, and the comet has reached the apex of its inward descent. It has entered the solar forge, a region of space where the laws of physics are dictated by the overwhelming presence of the central star. The sun is not merely a source of light. It is a violent, churning furnace of nuclear fusion, a sphere of white-hot plasma where hydrogen atoms are crushed into helium at a rate of 600 million tons every second. This gargantuan engine creates a localized environment of such intensity that it bends the very fabric of reality around it. The comet, a fragile assembly of ice and dust, now finds itself passing within 58 million kilometres of this incandescent surface. This distance, while vast by human standards, places the object well within the orbit of Mercury, deep inside the thermal heart of the solar machine. The thermal stress placed upon the nucleus is absolute. For 80,000 years, the comet was preserved in the perfect, lightless deep freeze of the outer reaches, but here it is subjected to a radiation flux thousands of times more powerful than anything experienced at the orbit of Earth. The dirty snowball is no longer merely subliming. It is being flayed alive. The sun's heat penetrates the dark, insulating crust, reaching the volatile reservoirs of water ice and frozen gases that have remained solid since the birth of the system. The internal pressure rises to a breaking point. The nucleus screams as jets of vaporized matter erupt with the force of volcanic explosions, tearing away chunks of the surface and hurling them into the expanding coma. The comet is a mountain in a kiln, a relic of ice struggling to maintain its structural integrity against the crushing weight of solar energy. In this crucible, the sun acts as a gravitational pivot. The cold machine utilizes the mass of the star to perform a maneuver of staggering kinetic significance. As the comet reaches perihelion, its velocity reaches its absolute maximum, accelerated by the sun's immense pull to a speed exceeding 200,000 kilometers per hour. This is the powered slingshot in action. The comet is not merely falling around the sun, it is being whipped through the curved space-time of the solar well. The gravitational force acts like a tensioned cord, catching the momentum of the incoming projectile and redirecting it with violent precision. This is the moment of the great turn, where the inward fall is converted into an outward flight. The environment of the solar forge is a chaotic tapestry of magnetic loops and solar gales. The comet must navigate through the corona, the Sun's outer atmosphere, where temperatures paradoxically soar to over 1 million degrees. While the density of this plasma is low, the magnetic fields of the Sun are unimaginably complex, twisting and snapping in the vacuum. These fields interact with the ionized gases of the comet's tail, causing it to flicker and dance like a candle in a storm. Occasionally, a coronal mass ejection, a billion-ton cloud of solar plasma, might lash out from the surface. If such a solar storm were to strike the comet at this range, the impact would be equivalent to a physical blow, potentially stripping the coma away entirely, or even shattering the fragile nucleus into 1,000 pieces. The comet is a speck of dust in the presence of a god. The Sun's diameter is over 100 times that of the Earth, 1,000,000-fold the volume of our world, and the comet is but a few kilometers wide. Yet, the laws of the machine apply to both with equal rigors. The conservation of angular momentum dictates that as the comet draws closer to the pivot, it must move faster, a celestial ice skater pulling in their arms to spin with dizzying speed. This kinetic energy is the only thing that saves the comet from being consumed by the furnace. If its velocity were even a fraction lower, the Sun's gravity would drag it across the event horizon of the solar surface, vaporizing it instantly in the nuclear fire. Instead, the comet skips across the gravitational potential, using its own speed to defy the pull of the star. As the turn is completed, the comet begins its retreat. It has survived the forge, though it emerges as a diminished version of its former self. It has sacrificed millions of tons of its mass to the heat, leaving behind a dense trail of dust and gas that marks the location of its perihelion passage. This debris remains in the solar forge, a lingering ghost of the comet's presence, while the nucleus itself is flung back toward the outer system. The slingshot has done its work. The projectile is now aimed directly toward the orbital path of the Earth, carrying with it the scars of its encounter with the Sun. The machine has processed the intruder, accelerated it, and redirected it with a mathematical certainty that ensures its next appointment will be with the Watchers on the third planet. The solar furnace fades into the distance, but the energy it has imparted to the comet will fuel the spectacular display that is yet to come. As the comet retreats from the solar forge, it enters a specific geometric alignment that triggers one of the most spectacular optical phenomena in the cold machine of the cosmos: forward scattering. This is a moment where the positioning of the Sun, the comet, and the Earth creates a celestial lens of staggering efficiency. Because the comet is passing almost directly between our world and the central star, we are not viewing it from the side, but rather looking through the vast, trailing shroud of its debris toward the light of the Sun itself. This orientation transforms the billions of microscopic dust grains within the tail into tiny, incandescent prisms. The physics of forward scattering is a matter of precise angular momentum, and the behavior of photons as they encounter matter. When sunlight strikes a particle of dust, it does not merely bounce off the surface, it is redirected, or scattered, in a forward direction. If the dust grains are of a specific size, roughly comparable to the wavelength of the light hitting them, they act as focusers, concentrating the solar energy and hurling it toward the observer. It is the same effect that causes a cloud to glow with a silver lining when it obscures the sun, or the way a dusty windshield becomes a blinding wall of white when driving into the sunset. In the vacuum of space, with a tail stretching for tens of millions of kilometers, this effect is magnified to a degree that defies the ordinary behavior of celestial objects. The dust tail of Tsuchinshan-ATLAS is particularly well suited for this display. Composed of silicates and carbonaceous grains liberated during the violent sublimation of the Perihelion passage, the tail is a dense reflective ribbon of ancient material. As the comet moves into position, these grains catch the flood of solar photons and funnel them toward the dark side of the Earth. The result is a surge in luminosity that can elevate the comet from a faint telescopic object to a beacon that tears through the twilight. This is not a gradual increase in brightness due to proximity. It is a sudden geometric spike in the intensity of light. To quantify this brilliance, astronomers utilize the magnitude scale, a logarithmic system where lower and negative numbers represent greater intensity. A star of magnitude 6.0 is at the very limit of human vision under a perfectly dark sky. The planet Mars often glows at a magnitude of 0, but as the forward scattering effect takes hold, the comet C/2023A3 is predicted to reach a magnitude of -3.0. This would make it nearly 15 times brighter than Sirius, the most luminous star in the firmament, and would place it in the same league as the planet Jupiter. At this magnitude, the comet becomes a dominant force in the evening sky, a sharp, piercing needle of light that refuses to be ignored. This brilliance is not a soft or diffused glow. It is a concentrated spear of light that appears to puncture the velvet curtain of the atmosphere. As the sun dips below the horizon, the comet will emerge from the glare, its head glowing with a fierce planetary intensity, while its tail fans out behind it like a scorched wing. The forward scattering ensures that even as the comet moves away from the sun, its perceived brightness remains high, sustained by the sheer volume of dust it has shed during its passage through the forge. It is a visual manifestation of the kinetic energy it has absorbed, a ghost of the solar furnace carried on a banner of light. The machine of the solar system has in this moment created a perfect alignment. The Earth acts as the sensor, the sun as the source, and the comet as the modulator. There is no intent in this arrangement, only the inevitable consequence of orbital paths intersecting at the correct angles. The light we see is information, data regarding the composition of the nucleus and the density of the tail, but to the eye it is a visceral intrusion of the cosmic into the mundane. The comet rivals the planets not because of its size, but because of its position within the clockwork. It's a temporary gear made of light, reflecting the power of the star that nearly destroyed it. In the nights following its closest approach to the sun, the comet will hang in the western sky, a reminder of the scale of the cold machine. The brilliance of -3.0 ensures that even from the centres of light-polluted cities, the intruder will be visible as a strange, elongated star. It is a rare occurrence in the human timeline, a moment where the geometry of the heavens conspires to make the invisible visible. The light of the comet, scattered and focused by millions of kilometres of ancient dust, serves as a beacon, marking the path of a projectile that has spent 80,000 years falling toward this single luminous moment. The gears continue to turn, the light continues to scatter, and the spectacle of the cold machine reaches its incandescent peak. The brilliance of the comet is a deceptive mask, a luminous veil that hides a structural fragility so profound it borders on the ethereal. While it appears as a world-tearing projectile, the nucleus of C/2023A3 is not a solid monolith of stone or iron. It is a tenuous architecture of ancient dust and volatile ices, a celestial rubble pile held together by the weakest of gravitational bonds. This mountain of frozen history is more akin to a compacted drift of soot and snow than to a planetary body. As it emerges from the solar forge, it carries with it the existential threat of its own disintegration. The very energy that makes it visible to the inhabitants of the Earth is the same force that seeks to tear it asunder, a phenomenon known to the watchers of the sky as the magnitude paradox. In this paradox, the brightness of a comet is often its death rattle. To the eye, a sudden spike in luminosity suggests a strengthening of the object, but to the cold logic of the machine, it often signals a catastrophic loss of integrity. As the internal pressures of vaporizing carbon monoxide and water ice build within the porous interior, the nucleus becomes a pressure vessel with no safety valve. If the heat of the sun penetrates too deeply or too quickly, the expansion of these gases can exceed the structural strength of the icy matrix. The nucleus does not simply melt, it explodes from within. This creates a temporary surge in brightness as millions of new surfaces are exposed to the sunlight, reflecting a sudden, brilliant flash of scattered light. But this brilliance is the herald of a ghost. Once the nucleus shatters, the individual fragments, no longer protected by a central mass, sublime at an accelerated rate, causing the comet to fade into a featureless cloud of dust within days. The sun exerts a secondary, more insidious force upon the intruder, the crushing power of tidal stress. Because the nucleus has a physical dimension, the side facing the sun experiences a slightly stronger gravitational pull than the side facing the deep void. At a distance of 58 million kilometers, this difference in force, the tidal gradient, acts like a pair of invisible hands grasping the comet and attempting to stretch it into an oblong shape. For a body as loosely consolidated as Tsuchinshan-ATLAS, this stretching can be fatal. The internal friction generated by these tidal forces adds more heat to the already scorched interior, further weakening the bonds between the dust grains and the ice crystals. The comet is caught in a mechanical vice, squeezed by gravity and baked by radiation, its very existence a gamble against the uncompromising laws of the machine. Astronomers monitor the light curve of the comet with the disciplined anxiety of engineers watching a failing turbine. They look for stuttering in the brightness, erratic fluctuations that suggest the nucleus is shedding large crustal plates or that the main body has already split into several smaller pieces. If the comet were to fragment, it would transform from a single, sharp needle of light into a string of pearls, a sequence of fading embers trailing along the orbital path. This would rob the world of its spectacular October display, leaving only a smear of telescopic debris where a great celestial monument should have been. The machine does not care if the comet survives its passage. It only cares that the momentum is conserved and the energy is dissipated. The nucleus is a masterpiece of primordial fragility. It has survived for 4.6 billion years in the deep freeze of the Oort Cloud, protected by the absolute zero of the periphery. Its sudden exposure to the solar furnace is a shock that the architecture of the object was never designed to withstand. The silicate dust, which acts as a dark, insulating blanket, can only do so much to ward off the relentless bombardment of solar photons. Below the soot, the ices are in a state of violent transition, turning into gas and seeking an exit. The comet is a crumbling wreck, a mountain of ancient waste that is being recycled by the solar engine. As it moves toward its closest approach to Earth, the question of its survival remains the primary variable in the mathematical model. Will the nucleus hold together, a battered but intact survivor of the forge, or will it arrive as a hollowed-out shell, a ghost of the projectile that was launched 80,000 years ago? The cold machine offers no guarantees. It provides only the arena and the forces. The comet must rely on its own internal cohesion, a legacy of the specific conditions of its birth in the early solar nebula. Every second it remains intact is a victory of matter over energy, a brief defiance of the destructive power of the star. The watchers on Earth wait, their sensors tuned to the frequency of a dying mountain, hoping that the architecture of ice and dust can endure one final movement of the gears before it reveals its full glory to the night. The calendar of the human species marks the day as October 12, 2024. On this evening, the orbital paths of the third planet and the visitor from the Oort Cloud reach their point of maximum convergence. The distance separating the two bodies is 0.47 astronomical units, a gap of approximately 70 million kilometers. In the vast, hollowed-out scale of the solar machine, this is a whisper of a distance, a graze of the gears that has been choreographed over a duration of 4.6 billion years. This is not a moment of peril for the soil beneath our feet. The projectile is aimed at the sky, not the crust. It is a near miss of exquisite precision, a mathematical inevitability that has been unfolding since the first grains of dust collided in the primordial nebula. As the sun sinks below the western horizon, the atmosphere of the Earth begins to act as a darkening filter, allowing the brilliance of the intruder to emerge from the solar glare. The Comet C/2023. A3 reveals itself as a temporary monument, a ghost of the early solar system haunting the modern era. It stands as a sharp, incandescent needle in the twilight, its nucleus glowing with a concentrated planetary light. Behind it, the tail fans out across the constellations, a luminous banner of ancient dust and ionized gas that spans tens of degrees of the celestial arc. To the observer on the ground, the comet does not appear to move. It hangs with a terrifying stillness, a frozen explosion of light that seems to dwarf the distant stars. The spectacle is a collision of timelines. Below, the cities of man are illuminated by the hum of the electric grid, a world of silicon, steel, and short-lived biological concerns. Above, the comet represents the deep time of the cold machine. The light reaching the eyes of the watchers is reflected from material that has remained unchanged since before the Earth possessed an atmosphere or a moon. This is the debris of the construction phase, the leftover scrap from the assembly of the planetary gears. To see the comet is to look directly into the face of the past, a visual link to the era when the solar system was a chaotic swirl of gas and fire. The geometry of 0.47 astronomical units ensures that the comet is large enough to be seen in 3 dimensions. Through the lens of a telescope or the steady gaze of a camera, the coma is no longer a point of light but a textured greenish shroud of gas, pulsing with the energy of the outgassing nucleus. The tail shows structure, delicate filaments of ions being whipped by the solar wind, and broad, sweeping curves of dust that trace the comet's orbital momentum. It is a masterpiece of fluid dynamics, operating in a vacuum, a visual representation of the forces of gravity and radiation pressure locked in a silent struggle. The indifference of the machine is perhaps most palpable during this closest approach. The comet does not recognize the world it is passing. It does not feel the gaze of the billions of eyes turned toward it, nor does it acknowledge the sophisticated sensors that are recording its every photon. It is a mass following a vector, a component of the engine performing its function. If the distance had been 0.047 units instead of 0.47, the encounter would have been an extinction-level event, a kinetic impact that would have vaporized the atmosphere and reset the biological clock of the planet. But the gears were set long ago, and the clearance is sufficient. We are granted the privilege of the spectacle without the price of the catastrophe. As the night deepens, the comet descends toward the horizon, following the rotation of the Earth. It appears to sink into the silhouettes of mountains and the jagged skylines of cities, a celestial visitor briefly touching the terrestrial world. The watchers feel a sense of profound, quiet weight, a realization that they are witnessing a singular event in the history of their species. This mountain of ice has travelled for 80,000 years to reach this specific coordinate in space and time. It will not return for another 80,000, by which time the cities below will likely be dust, and the languages spoken tonight will be forgotten. The comet is a reminder of the transience of the observer compared to the endurance of the machine. The evening of October 12th is the climax of the narrative. The projectile has reached the inner sanctum, survived the solar forge, and now makes its closest pass to the world of the living. It is the moment where the abstract mathematics of orbital mechanics become a visceral visual reality. The cold machine has brought 2 disparate parts of its assembly together for a brief, luminous encounter, allowing the biological noise of the third planet to witness the silent grinding glory of the gears. As the comet begins to pull away, moving back toward the dark, it leaves an indelible mark on the collective consciousness of the watchers, a ghost of the beginning, passing through the middle, on its way to an infinite end. The spectacle in the twilight sky is a mask for a more terrifying reality, the absolute and unwavering indifference of the cosmos. The Comet C/2023 I3 does not possess a destination, nor does it harbour a purpose. It is a mass of matter obeying the dictates of a cold machine, a gear that has been set in motion by the blind application of force. There is no cosmic plan that brought this mountain of ice to our doorstep, no celestial providence ensuring our safety, and no ancient prophecy guiding its path. The universe operates with a complete lack of intent or conscience. It is a system of variables and constants, a vast numerical engine where the lives of billions are merely a statistical byproduct of a stable planetary orbit. The precision of the current encounter is a testament to the mechanical nature of existence. When the comet was first nudged from its resting place in the Oort Cloud 80,000 years ago, the angle of its descent was determined by the random alignment of distant stars and the subtle, unfeeling tug of galactic tides. Had that initial force been different by only a few degrees, the trajectory would have been altered in a way that would have fundamentally changed the history of the third planet. A minor shift in the starting vector, magnified over the trillions of kilometers of its journey, could have placed the Earth directly at the center of the comet's kinetic path. In such a scenario, the cold machine would not have hesitated. The laws of momentum and gravity do not pause for the existence of art, philosophy, or the complex tapestries of human civilization. If the projectile had been aimed just a fraction of a degree closer to our orbital coordinate, the encounter on October 12th would not have been a visual wonder, but a terminal event. The comet, travelling at over 70 kilometers per second, would have struck the atmosphere with the kinetic energy of billions of nuclear warheads. The resulting explosion would have torn the sky asunder, vaporizing the crust and plunging the world into a multi-generational winter of dust and ash. Human history, with all its triumphs and tragedies, would have been extinguished with the same lack of emotion as a heavy iron gear crushing a speck of dust on its surface. The machine would continue to turn, the sun would continue to burn, and the vacuum of space would remain as silent as it was before the first multicellular life emerged from the oceans. This realization strips away the comfort of human-centric mythology. We often seek to find meaning in the heavens, to see signs and portents in the movement of the stars. But the comet Tsuchinshan-ATLAS is a reminder that we inhabit a universe that does not see us. The cold machine motif is not a metaphor. It is a description of the fundamental reality of the physical world. The forces that govern the motion of the comet are the same forces that govern the beating of a human heart and the collision of galaxies. These forces are blind. They do not distinguish between the birth of a star and the death of a species. Both are merely the redistribution of energy and matter according to the laws of thermodynamics. The fragility of our position within the machine is highlighted by the sheer scale of the objects in motion. The Earth is a small rocky gear spinning in a narrow habitable zone, protected by a thin layer of gas that is easily disrupted. The comet is a reminder of the debris that litters the engine room, the loose parts that can at any moment be caught in the gears. We exist because the machine has thus far operated with a stability that favours our continued presence. Our safety is not a guarantee, it is a mathematical fluke, a period of calm in a system that is capable of extreme violence. Yet, there is a strange, piercing clarity to be found in this indifference. By acknowledging that the universe does not care, we are forced to recognise that the only meaning to be found is that which we create ourselves. The comet is not a god, nor is it a demon. It is a piece of ice and dust. The fear we feel at the thought of its impact and the wonder we feel at the sight of its tail are entirely human constructs. We are the only part of the machine that has developed the capacity to feel, to observe, and to assign value to the motion of the gears. In the face of a cold and unfeeling cosmos, our ability to find beauty in the mechanism is our only rebellion. As the comet begins to fade from our sky, retreating back into the dark from which it came, it leaves behind a profound sense of our own insignificance. We have watched a mountain fall from the edge of the solar system, graze our world, and be flung back into the abyss. The machine has performed its function with terrifying precision. We are still here, not because the universe wished it so, but because the vectors did not intersect. We remain as passengers on a small spinning gear, watching the silent, grinding clockwork of the heavens, forever aware that the next movement of the machine could be as indifferent to our end as it was to our beginning. The cold machine does not know it exists. The sun does not feel its own heat, and the comet C/2023A3 does not know it is a mountain of ice. But within this relentless assembly of gravity and momentum, there is a small, improbable complication: the human mind. We are the only part of the mechanism that has developed the capacity to turn around and look back at the gears. We are made of the same primordial dust that forms the comet's tail, and the same heavy elements forged in the hearts of dying stars, yet through some strange alchemy of evolution, we have become the eyes and the consciousness of the machine. When the astronomers at the Purple Mountain Observatory first logged that faint smudge of light, they were doing more than just recording data. They were engaging in an act of profound defiance against the indifference of the void. By using the laws of physics, the same laws that drive the comet, to predict its arrival, we have transformed a potentially terrifying encounter into a masterclass of logic. We have mapped the invisible curves of space-time with nothing but light and mathematics. We know exactly where the comet was 80,000 years ago, and we know exactly where it will be 80,000 years from now. This ability to project our understanding across the abyss of time and space is what separates us from the unthinking rocks that share our system. This mastery of logic does something remarkable to the human spirit. It transforms fear into a profound sense of gratitude. A species that did not understand the machine would look at the comet and see an omen of doom, a jagged sword hanging in the twilight. But a species that has mapped the gears sees a rare and beautiful alignment. We recognize that we are fragile entities, biological organisms whose lives are but a flicker in the timeline of the solar system. Yet we are here, at this precise moment, to witness the passage of a relic. The mathematical odds against our existence, combined with the mathematical odds of this comet passing so close to our world, create a sense of wonder that is more powerful than the fear of the dark. We are the witness. Without an observer, the cold machine is a masterpiece with no audience, a clock ticking in an empty room. The comet would sublime, the sun would burn, and the planets would orbit in a silence that has no meaning. But because we are here, the machine gains a purpose it does not possess on its own. We give the light a name. We categorize the dust and the ions. We find beauty in the geometry of a retrograde orbit. In doing so, we become a vital component of the system, not because we have the power to change the path of the gears, but because we are the only ones who can appreciate the complexity of the movement. This realization brings a strange sense of peace. The universe may be indifferent, but our observation of it is an act of intense, focused care. We have built great glass eyes to peer into the dark and complex computers, to crunch the numbers of the Oort Cloud. We have shared the images of the comet across a global network, ensuring that every member of our species can see the ghost of the early solar system. This collective act of observation is a celebration of our place in the machine. We are the part of the universe that has decided to pay attention. As the comet Tsuchinshan-ATLAS reaches its zenith in our sky, we are reminded that our fragility is also our greatest strength. Because our time is short, we value the moment. Because our world is small, we cherish the vastness. The comet, with its 80,000-year cycle, serves as a yardstick for our own history. It was last here when the human mind was just beginning to grasp the concept of the stars. It will return when we have either transcended our current form or vanished entirely. In either case, the fact that we saw it today, that we understood its path and marvelled at its brilliance, is a victory of the spirit over the cold, mechanical reality of the void. We are the consciousness of the machine, and for a few brief nights in October, we have given the universe a reason to shine. The gratitude we feel is not for the comet itself, but for the capacity to know it. We're grateful for the light that travelled 70 million kilometres to reach our retinas, and for the billions of years of evolution that allowed us to interpret that light as a thing of beauty. We are fragile, yes, but we are also the only entities capable of mapping our own potential destruction with a smile of wonder. This is the human element, the ability to stand before the grinding gears of the cosmos and find not just terror, but a deep and abiding sense of belonging. We are part of the machine, but we are the part that remembers. The light of the comet continues to fade as it moves toward the outer reaches, but the data remains, and the memory of its passage is etched into the logs of our observatories and the minds of the watchers. The machine will continue to turn, indifferent as ever, but for one brief moment it was observed, it was understood, and it was loved. That is the purpose we bring to the dark. That is the meaning of our existence in the cold, silent clockwork of the heavens. We are the ones who look back. The momentum that carried the projectile into the incandescent heart of the solar forge now drives its long, silent retreat. Having reached its peak velocity and survived the crushing tidal forces of the Sun, C/2023, A3 begins the slow climb out of the gravitational well. The brilliant needle of light that pierced the twilight of October starts to dim, its fierce planetary intensity fading back into the grey anonymity of a telescopic smudge. The forward scattering geometry, which for a few nights turned the comet's tail into a beacon of scattered fire, is now shifting. As the angle between the Earth, the Sun, and the comet widens, the optical magic dissipates, leaving behind a cooling mountain of ice that has already begun its return to the deep freeze of the outer dark. The retreat is a mirror of the arrival, yet the comet is forever changed. It has sacrificed millions of tons of its primordial mass to the solar furnace, leaving a trail of dust that will linger in the inner solar system for centuries. As it crosses back over the orbital path of Mars, the process of sublimation slows. The violent geysers of vaporized gas and ancient soot begin to quiet, and the expansive coma, once larger than the planet Jupiter, starts to collapse under the lack of solar pressure. By the time the comet reaches the orbit of the gas giants, the internal heat will have dissipated, and the nucleus will once again be encased in a shell of absolute cold. The chemical awakening is over. The ghost of the early solar system is going back to sleep. The timeline of this departure is a staggering reminder of the scale of the cold machine. The comet will not return to this coordinate for another 80,000 years. To consider this span of time is to recognize the profound transience of the biological world compared to the mechanical endurance of the cosmos. 80,000 years ago, when this object last saw the sun, the human species was a local phenomenon, its ancestors carving bone and stone in the shadows of an ice age. The stars in the sky were arranged in different patterns, and the very concept of a telescope was tens of millennia away from being conceived. When the comet returns 80,000 years from now, the world it visits will be unrecognizable. The cities that watched its passage in 2024 will be geological layers, and the languages used to describe its beauty will be silent echoes in the fossil record. The machine does not wait for us to catch up. The gears of the planets will continue to grind, the sun will continue its slow evolution toward a red giant, and the Oort Cloud will remain a silent reservoir of icy relics, undisturbed by the rise and fall of civilizations. We are a species that exists in the briefest of intervals between the movements of the celestial clock. Yet, as the comet vanishes into the dark, it leaves behind a legacy of data and wonder. We have mapped its path, analysed its chemistry, and recorded its brilliance. We have used our brief moment in the light to understand a cycle that dwarfs our entire history. This is the triumph of the observer, to find meaning in a mechanism that possesses none. The departure of Tsuchinshan-ATLAS marks the end of a chapter, but the story of the cold machine is infinite. The solar system is a vast assembly of such movements, a clockwork that is constantly resetting, aiming new projectiles, and refining the orbits of its gears. There are billions of other icy mountains waiting in the dark, each a potential messenger from the dawn of time, each a reminder of the precision and the indifference of the universe. We remain on our small spinning world, our sensors always tuned to the dark, waiting for the next smudge of light to emerge from the background noise of the stars. To observe the universe is to participate in its grandest design. While the cosmos may not feel our presence, our act of witnessing gives the silent grinding of the gears a voice. We invite those who have felt the weight of this celestial encounter to remain a part of this grand observation. The journey through the clockwork of the heavens is a continuous one, a path paved with light and logic that leads to the very edges of existence. By joining this community of watchers, by subscribing to the ongoing chronicle of the stars, the journey into the heart of the history of the universe continues. Together, we will continue to map the trajectories of the unknown, to analyse the heat of the furnaces and the cold of the voids, and to seek the next great alignment in the relentless, beautiful engine of the cosmos. As the comet C/2023A 3 crosses the threshold of the outer system and vanishes into the lightless abyss, we turn our eyes toward the next movement. The cold machine never stops. The gears are already turning for the next encounter, the next discovery, and the next moment of profound, piercing clarity. We are the ones who look back at the dark, and we are the ones who will be here when the next ghost of the primordial past screams into the light. The story of the universe is our story, written in the language of gravity and read by the light of the stars. Join us as we continue to turn the pages of the infinite.